This video will give you a quick overview of EMPro, a 3D modeling and simulation environment that is part of the ADS design flow. EMPro allows you to draw or import 3D structures, then either analyze them directly with two different EM simulators, or place them on an ADS layout, so the combination of the 3D structure and 2D layout can be analyzed with the EM simulation. Let's begin with the EMPro drawing environment. There are many advanced drawing features and automation tools, so you can quickly create complex 3D structures. Geometries can be fully parameterized, so you can quickly change the dimensions and do what-if analysis. In EMPro, we can also import 3D structures from other CAD environments. EMPro supports SAT files and several other formats. These file formats typically provide information about physical dimensions but not material properties, so once a structure is imported into EMPro, the material properties can be defined by selecting materials from the default materials library or defining your own materials. Then the materials can be assigned to the structure by simply dragging them onto each part in the project tree. An ADS layout file can also be imported into EMPro with a single mouse click in ADS. This brings up the EMPro environment and recreates the layout in EMPro. The material properties and simulation port definitions are already included and do not have to be set up manually in EMPro. So once the ADS layout is imported, you're ready to simulate. Once our structure has been created or imported, we can simulate it either in EMPro directly or in ADS. In this example, we have created a 3D mechanical shield in EMPro, and now we can place it as a fully parameterized 3D EM component on a microwave filter design in ADS. Before launching a simulation, we can preview the combination of the 3D component and the layout. Then we can simulate directly from ADS using the finite element method, or FEM, simulator. The result is a full 3D simulation of both the 3D shield component and the filter layout, so all of the EM interactions between them are accounted for in the simulation. Sometimes we want to partition our design and simulate one portion using circuit simulators and another portion using 3D EM. In this board-level VCO design in ADS, the portion of the design on the left is represented as a schematic, and the portion on the right is a layout component that contains a board layout and a surface mount dielectric resonator. The resonator was created in EMPro and brought into ADS as a parameterized 3D EM component, so that the parasitic coupling between the resonator and the board vias is accurately captured. With this design, we can now run a circuit EM co-simulation in ADS, with the finite element simulator running on the layout, including the 3D dielectric resonator component, and the harmonic balance simulator running on the schematic portion of the design. 3D EM simulations can also be run directly in EMPro using either finite element method or finite difference time domain. Each has its benefits for various applications. FDTD is a time domain simulator and very good for electrically large problems like antenna analysis, radar cross-section analysis, regulatory compliance tests such as specific absorption ratio and hearing aid compatibility, and EMI and TDR analyses. FEM is a frequency domain simulator and is best for looking at the frequency response of RF board and module designs, RFIC packaging applications, and other RF connectors and components. To summarize, EMPro delivers the industry's most modern 3D EM modeling environment for creating 3D structures. EMPro is integrated with the ADS flow, allowing you to place parameterized 3D components directly on an ADS layout and run EM simulations from within ADS, or you can import ADS layouts into EMPro. Simulations can also be run in EMPro with both frequency domain and time domain 3D EM simulation technologies, which cover a broad range of RF, microwave, and high-speed digital applications. Thanks for watching. Please visit the EMPro web pages for more information or request a free trial.